Welcome. Today, we are looking at heat and temperature. This is topic 7 in your SS1 physics series. This topic is frequently tested in your examinations. Pay close attention. Let us begin. First, let me explain what heat is. Heat is a form of energy. It is the energy that flows from a hotter object to a colder object. Heat is measured in joules. Heat is a scalar quantity. It has magnitude, but no direction. Heat flows due to a temperature difference. The direction of heat flow is always from hot to cold. This is a fundamental principle of physics. Heat is essential for many processes. It is essential for life. It is essential for industry. Understanding heat is essential for understanding thermodynamics. Now, let me explain what temperature is. Temperature is a measure of the average kinetic energy of the particles in a substance. It is a measure of how hot or cold a substance is. Temperature is measured in degrees Celsius, Kelvin, or Fahrenheit. Temperature is a scalar quantity. It is a property of a substance. Temperature determines the direction of heat flow. Heat flows from high temperature to low temperature. Temperature is different from heat. Heat is energy. Temperature is a measure of the average kinetic energy. Understanding the difference between heat and temperature is essential in physics. Now let me explain the difference between heat and temperature. Heat and temperature are often confused. Heat is energy. Temperature is a measure of energy. Heat is measured in joules. Temperature is measured in degrees Celsius or Kelvin. Heat depends on the amount of substance. Temperature does not depend on the amount of substance. For example, a large pot of water at 100 degrees Celsius has more heat than a small cup of water at 100 degrees Celsius. But both have the same temperature. Heat flows from hot to cold. Temperature determines the direction of heat flow. Understanding this difference is essential for understanding thermal physics. Now, let me explain the concept of internal energy. Internal energy is the total energy of the particles in a substance. It includes kinetic energy and potential energy. Kinetic energy is the energy of motion. Potential energy is the energy of position. Internal energy depends on temperature and the state of the substance. When heat is added to a substance, its internal energy increases. When heat is removed, its internal energy decreases. Internal energy is measured in joules. Understanding internal energy is essential for understanding thermodynamics. Now, let me explain thermal equilibrium. Thermal equilibrium occurs when two objects have the same temperature. When two objects at different temperatures are in contact, heat flows from the hotter to the colder object. The flow continues until both objects reach the same temperature. At thermal equilibrium, there is no net flow of heat. Thermal equilibrium is a fundamental concept in thermodynamics. It is essential for understanding heat transfer. Now, let me explain the methods of heat transfer. Heat can be transferred in 3 ways: conduction, convection, and radiation. Conduction is the transfer of heat through a material. It occurs without the movement of the material itself. Conduction occurs when particles collide and transfer energy. Metals are good conductors. They have free electrons that transfer heat quickly. Nonmetals are poor conductors. They are called insulators. Examples include wood and plastic. Convection is the transfer of heat through fluids. Fluids include liquids and gases. Convection occurs when hot fluid rises and cold fluid sinks. This creates a convection current. Convection is responsible for many natural phenomena. Examples include ocean currents and atmospheric circulation. Radiation is the transfer of heat through electromagnetic waves. It does not require a medium. Radiation can occur through a vacuum. The sun radiates heat to the earth. Radiation is responsible for many natural phenomena. Understanding heat transfer is essential for many applications. It is essential for engineering and everyday life. Now, let me explain conduction in detail. Conduction is the transfer of heat through a material. It occurs when particles collide and transfer energy. The rate of conduction depends on the material. Metals are good conductors. They have free electrons that transfer heat quickly. Copper and aluminum are excellent conductors. Non-metals are poor conductors. They are called insulators. Wood, plastic, and rubber are insulators. Conduction is important in many applications. It is used in cooking, insulation, and electronics. Understanding conduction is essential for engineering and everyday life. Now, let me explain convection in detail. Convection is the transfer of heat through fluids. Convection occurs when hot fluid rises and cold fluid sinks. This creates a convection current. Convection is responsible for many natural phenomena. Ocean currents are caused by convection. Atmospheric circulation is caused by convection. Convection is used in heating systems. Radiators heat air by convection. Convection is important in many applications. Understanding convection is essential for engineering and everyday life. Now, let me explain radiation in detail. Radiation is the transfer of heat through electromagnetic waves. It does not require a medium. Radiation can occur through a vacuum. The sun radiates heat to the earth. Radiation is responsible for many natural phenomena. All objects emit radiation. Hotter objects emit more radiation. Radiation is used in many applications. It is used in cooking, heating, and communication. Understanding radiation is essential for engineering and everyday life. Now, let me explain specific heat capacity. Specific heat capacity is the amount of heat required to raise the temperature of 1 kilogram of a substance by 1 degree Celsius. It is measured in joules per kilogram per degree Celsius. The formula for specific heat capacity is C equals Q over M times delta T. C is specific heat capacity, Q is heat, M is mass, and delta T is change in temperature. Different substances have different specific heat capacities. Water has a high specific heat capacity. It requires a lot of heat to change its temperature. Metals have low specific heat capacities. They require less heat to change their temperature. Specific heat capacity is important in many applications. It is used in cooking, heating, and cooling. Now, let me explain thermal expansion. Thermal expansion is the increase in size of a substance when its temperature increases. Most substances expand when heated. They contract when cooled. Thermal expansion occurs because particles move more when heated. They take up more space. Thermal expansion is important in many applications. It is used in thermometers, thermostats, and bridges. Expansion joints are used in bridges to allow for thermal expansion. Understanding thermal expansion is essential for engineering and everyday life. Now, let me explain the expansion of solids. Solids expand when heated. They expand in all directions. The expansion depends on the material. Different materials expand at different rates. The formula for linear expansion is delta L equals alpha times L times delta T. Delta L is change in length. Alpha is the coefficient of linear expansion. L is original length. Delta T is change in temperature. The formula for volume expansion is delta V equals beta times V times delta T. Beta is the coefficient of volume expansion. Thermal expansion is important in many applications. It is used in construction and manufacturing. Now let me explain the expansion of liquids. Liquids also expand when heated. Liquids expand more than solids. The expansion depends on the liquid. Different liquids expand at different rates. Water is unusual. It expands when cooled below 4 degrees Celsius. This is called the anomalous expansion of water. This property is important for aquatic life. It allows ice to float on water. Understanding the expansion of liquids is important in many applications. It is used in thermometers and engines. Now, let me explain the expansion of gases. Gases expand significantly when heated. Gases have the highest coefficient of expansion. The expansion of gases is described by the gas laws. Charles's law states that the volume of a gas is directly proportional to its temperature at constant pressure. The volume increases as temperature increases. The volume decreases as temperature decreases. Understanding the expansion of gases is essential for understanding thermodynamics. It is used in engines and refrigeration. Now let me explain the applications of thermal expansion. Thermal expansion has many applications. It is used in thermometers. Thermometers use the expansion of liquids to measure temperature. It is used in thermostats. Thermostats use the expansion of metals to control temperature. It is used in bridges. Expansion joints allow bridges to expand and contract. It is used in railway tracks. Gaps are left between rails to allow for expansion. It is used in pipes. Pipes have expansion loops to allow for expansion. Understanding thermal expansion is essential for engineering and everyday life. Now, let me give you sample exam questions. Define heat. Heat is a form of energy that flows from a hotter object to a colder object. Define temperature. Temperature is a measure of the average kinetic energy of the particles in a substance. Distinguish between heat and temperature. Heat is energy. Temperature is a measure of energy. State the three methods of heat transfer: conduction, convection, and radiation. Explain the concept of thermal expansion. Thermal expansion is the increase in size of a substance when its temperature increases. State the formula for specific heat capacity. C equals Q over M times delta T. Let me summarize. Heat is a form of energy. Temperature is a measure of the average kinetic energy of particles. Heat flows from hot to cold. Thermal equilibrium occurs when temperatures are equal. Heat is transferred by conduction, convection, and radiation. Specific heat capacity is the heat required to raise the temperature of 1 kilogram by 1 degree Celsius. Thermal expansion is the increase in size when temperature increases. Understanding heat and temperature is essential for physics. Practice these concepts. When you have them down, move to topic 8.